Hey folks, how we doing? We're on page 174, number 4. Got some butternut squash, and evidently it is growing and it germinates. Oh, suitable approximation. Okay, so we got a good clue here. So you take a look. Got 250 seeds, and we got an independent probability that they're going to germinate. All right, this looks like a binomial distribution. So we know that there were 250 trials. Every seed is a trial, and we know that the probability of success is 0.86. Well, now I want to do an approximation, so I'm going to make it a normal distribution. So to find the mean, I take 250 times 0.86, and I get 215. And then I take 215 and multiply that times 0.14, Q, and I get the variance. So now I've got my mean and I got my variance. And so now I've got my normal distribution, and so I can just treating this like this. They want me to find the probability that V is greater than 210. And I change it to V to let people know that it's an approximation. Anyway, so I got to standardize this with the Z values. Now what I've got to keep in mind is that it's got to be greater than 10. That means it doesn't include 10. So when it's an approximation, we're going to do a half above or a half below. In this case, we're going to do a half above because it is going to be not including the 10. So if I want a number that's not including the 10, that's going to be 210.5. It'll round to 11. Anyway, so now when I go ahead and do all that stuff, I'm going to find out that the probability of Z is greater than negative 0.8202. All right, so if you sketch a quick graph, that means negative 0.8202 is somewhere over here. And I want to know what's greater than it. Now, of course, we can't do that. So if I use the symmetry of the graph, I realize that if I go over here to 0.8202 positive, and if I do everything to the left of it, that will be the same size, the same area. So I go ahead and do that. I look at my table, I go to 0.8, and then I go to 0.82. I drop down, and that's my number. And since the number after it's a 0, I'm going to go with this, and that's going to be 0.7939. And I'll round to 3 significant figures, and I'll end up with 0.94. And that's all there is. All right, thanks for watching.